This is called the proof part 2 of the circle theorem centre equals 2 edge. Now, you might think we've already proved the theorem, and we kind of have, we're basically there, but actually our proof from before, I'll just quickly slide it in, had a diagram like that, and had a diagram like that. That actually only proves it for one kind of diagram, one kind of configuration. There's another kind of configuration for this theorem where it's still true. Let me see if I can get it. Where what you have is your angle at the centre, but your angle at the edge is sort of crosses over, one of the lines crosses over. So we want to show that this angle here is half as big as the angle sort of in the middle there. How are we going to do that? Well, it starts the same. It starts the same idea. You draw a line from your angle at the edge to the centre and extend it. But now we haven't split the angle that we're interested in, that's this little black angle, into two parts at all. What we've actually done is we've ended up with a couple of new angles, this sort of red angle there, and this kind of blue angle there, which I'm going to call x and y, like in the previous ones. And the angle we're interested in is now no longer x plus y, but it's the red angle minus the blue angle. Okay, let's soldier on. We've got lots of isosceles triangles to play with. Here's a radius, going from there to there. Here's another radius, an isosceles triangle, so this angle here must also be x. If I call that one x there. X is the whole big angle. If I call this blue angle y, then there's another isosceles triangle that includes y, this radius, and that long side. It means that that is angle y. Okay, so I'm just to clarify, I'm going to write this already. The angle at the centre, in the previous proof, was x plus y. It's now actually x minus y. Okay, good. Let's carry on. Let's have a look at what this huge angle here is. Okay. Well, let's put in, last time we called it dot. Dot is up there. X plus dot in this triangle is 180. So dot's 180 minus 2x. So dot plus this is also 180. So this angle here is actually 2x. Okay, I'm not sure if that's very clear, but that angle all the way around there is 2x. And again, we're a bit short on space, but there's an angle sort of cross in there somewhere. And because of this isosceles triangle, you can chase it round that this angle here is 2y. And then if you look very carefully, the angle that we're interested in, the angle at the centre, is this red angle, 2x, minus 2y. So we get angle... I'm so sorry, I've made a terrible mistake. That's the angle at the edge. Don't listen to me. The angle at the centre is 2x, take away 2y. So it's different from the previous proofs, but the conclusion that the angle at the centre is twice as big as the angle at the edge is still always true.